Today we have before us a group of physics students who want to prove Newton's laws of motion. To prove Newton's first law of motion, the students used a model car. Newton's first law is commonly referred to as the law of inertia. Inertia is a property of matter that will continue in its existing state of rest or motion unless the force is changed by an external force. The law of inertia simply states that an object at rest will stay at rest, while an object in motion will stay in motion, unless acted upon by an external force. For this demonstration, the car is experiencing equilibrium. Forces before it is set into motion by an external force. An object is facing equilibrium forces when it is either at rest or in a uniform motion, but it has the forces acting on the object are the same size, but are acting in opposite directions. In this case, the student is the first external force that the car faces, followed by the wall that the car hits, causing the object at rest to go into motion. After proving the first law, the students move on to Newton's second law, which involves acceleration, the rate of change of velocity an object has per unit of time, mass, the quantity of matter as determined from its weight, and net force, the total sum of all outside forces acting on a system. This law states that an object's acceleration is directly proportional to the object's net force and inversely proportional to the object's mass, which can be shown as in the equation A equals F net divided by m, where a is the acceleration, F net is net force, and m is mass. In this example, the student shows that the acceleration of the heavy-massed object, the wooden block, is very low due to the amount of net force the wooden object has, and because the object has a significant amount of mass. Next, the students move to Newton's third law of motion, which deals with the action and reaction forces. Action and reaction forces are the pair of forces in every interaction between two objects that are acting on said objects. In short, Newton's third law states that every action has an equal and opposite reaction. The action is a student pulling the paper that is underneath the water bottle, and the reaction is the water bottle dropping down a bit, then slightly shaking. This is due to the normal force changing and the friction between the moving paper and the water bottle. The normal force changed from the support force between the bottle and the paper to the support force of the bottle and the desk.